Sparky here, ready to fetch the key points. Welcome to From Seeds to Streams, exploring Belizean savannas and wetlands. Let's make this short and sweet. In the dense jungles and sprawling savannas of Belize, survival begins with a simple but critical challenge. How does a plant, rooted firmly in the ground, ensure its offspring find a place to thrive? This brings us to the fascinating world of seed dispersal. For most plants, it is not desirable for a seedling to sprout right next to its parent. If they grow too close, they end up competing for the same sunlight, water, and soil nutrients, which limits the growth of both. To solve this, plants have evolved ingenious ways to move their seeds across the landscape. One of the most common and effective methods is the use of a movable reward. Think of this as an employment contract between the plant and the animal kingdom. The plant produces a delicious, colorful fruit that acts as an incentive. Animals eat the fruit, seeds and all, and as they move through the environment, they eventually deposit those seeds in new locations, often along with a bit of natural fertilizer. In the Belizean bush, you will see this frequently with legumes. These are plants that produce seeds inside pods, much like the beans we eat. A beautiful example is the scarlet calliandra, which produces vibrant red, frilly flowers and seed pods that can actually pop open in the heat, though many legumes rely on creatures to carry them away. However, life for a plant isn't just about spreading seeds. It is also about protecting itself from being eaten before it can reproduce. Because plants cannot run away from predators, they have developed two main types of protection: chemical and structural defenses. Chemical defenses are a form of internal warfare. Many plants produce secondary compounds like alkaloids, cyanides, or terpenoids. If you have ever seen a plant produce a thick, milky sap or resin when a leaf is broken, you are seeing this defense in action. This milk can be toxic or incredibly irritating. If an animal eats it, they might become sick, disoriented, or even die. In Belize, famous examples include the black and white poisonwood trees. These trees carry chemicals so potent they can cause severe skin rash to anything that disturbs them, ensuring the plant's survival by making it a very unattractive snack. When chemicals aren't enough, plants turn to structural defenses. These are the physical barriers we can see and feel. Sharp projections, thorns, and spines on trunks or leaves are all employed to discourage herbivory, which is just a fancy way of saying they don't want to be eaten by animals. Whether it is the classic thorn of a rose or the formidable spikes on a tropical tree trunk, these physical traits make it painful or difficult for a creature to get close. Even the sandpaper tree uses a structural defense. By combining these clever dispersal strategies with robust defense mechanisms, the flora of Belize ensures that the next generation of life is always ready to take root. In nature, survival is rarely a solo effort, and one of the most fascinating ways life thrives is through symbiosis. At its core, symbiosis describes a close, long-term relationship between two different species. In the lush landscapes of Belize, this often takes the form of a specialized partnership between plants and biting insects. This isn't just a casual interaction. It is a highly evolved strategy where both parties depend on one another to stay alive and healthy. If you have ever walked through the savanna or the edge of a broadleaf forest, you might have noticed these plants with large hollow thorns that look a bit like bullhorns. These thorns aren't just for show. They serve as a fortified apartment complex for biting ants. The plant provides the ants with a safe place to live inside these hollow structures, and it even goes a step further by offering a movable reward in the form of food. These plants produce specialized structures called Belizean bodies, which are protein-rich nectaries found at the tips of their leaves. The ants feed on this nectar and these nutrient-packed tips, getting everything they need to sustain their colony without ever having to leave the plant. In return for this room and board, the ants become the plant's personal security detail. They are incredibly aggressive and will viciously attack anything that disturbs their host. If a grazing animal, like a deer or a cow, tries to take a bite of the leaves, the ants swarm out and deliver painful stings to the intruder's sensitive nose and mouth. But the protection doesn't stop defending against herbivores. These ants also act as gardeners. They are known to clear away competing vegetation that might try to grow too close to the base of their host plant. By biting off the shoots of neighboring vines or seedlings, the ants ensure that their tree doesn't have to compete for sunlight, space, or precious soil nutrients. This is a perfect example of mutualism, where the insect lives in the plant and feeds from it, but does not kill it. Instead, the animal protects the plant against competition and interference, ensuring the plant can grow tall and strong, while the ant colony remains well-fed and protected from predators. It is a remarkable defensive alliance that shows just how interconnected the ecosystems of the savanna and wetlands truly are. Even the smallest insect can play a massive role in the survival of a towering tree. As we move away from the dense, shaded canopy of the broadleaf forest, the landscape shifts dramatically into the Belizean savanna. This ecosystem is a world of open horizons and striking contrasts, defined by vast stretches of flat grassland dotted with scattered, solitary trees. Unlike the jungle, which feels like a closed room, the savanna is a wide open frontier where the sky dominates the view. When you stand in a savanna, you immediately notice that the structure is much simpler. It is primarily a sea of grasses with occasional clumps of individual trees, rather than a continuous forest. These trees often appear in small groups or stands, standing like islands in a grassy ocean. To truly understand why the savanna looks the way it does, we have to look beneath our feet at the soil, which is the architect of this entire ecosystem. The soil here is not the rich, dark loam you might expect in a tropical paradise. Instead, it is characterized by extreme conditions that dictate exactly what can survive. The primary feature of savanna soil is its high acidity. On the pH scale, these soils typically register between 4 and 5. To put that in perspective, a neutral pH is 7, and a healthy garden usually sits around 6.5. A pH of 4 or 5 is so acidic that it proves toxic or inhospitable to the vast majority of tropical plant species. This is the main reason you don't see the massive, diverse trees of the broadleaf forest encroaching on these plains. They simply cannot tolerate the chemical makeup of the ground. Beyond acidity, the soil is notoriously infertile. It is largely composed of coarse sand and silica, often derived from ancient granite formations. Because it is so sandy, it lacks the essential nutrients that most plants need to thrive. This sand often sits atop a layer of impermeable clay. This layering creates a double challenge. During the rainy season, the clay prevents water from draining away, causing the land to become waterlogged and swampy. Then, during the dry season, the sandy surface dries out completely, baking under the sun until it cracks. You might notice the soil has a distinct yellow or reddish tint, which come from the presence of minerals like iron and magnesium. These minerals, along with silicon and aluminum, are the remnants of weathered rocks like granite. This unique combination of high acidity, low nutrients, and poor drainage creates a harsh environment where only the toughest, most specialized plants can grow. It is an ecosystem defined not by what it has in abundance, but by the remarkable ways life has adapted to its scarcity and chemical intensity. To understand why the Belizean savanna looks the way it does, we have to look beneath the surface at the remarkable and challenging soil that defines this environment. Unlike the rich, dark loam you might expect in a tropical paradise, savanna soil is a study in environmental extremes. It is primarily characterized by a unique physical and chemical makeup that dictates exactly what can survive here. Most of this soil is composed of a layer of sand sitting atop impermeable clay. This means that instead of water seeping away quickly as it does in limestone areas, the clay holds the water, often leading to saturated, waterlogged conditions during the rainy season. The chemical story of this soil begins with granite. In areas like the mountain pine ridge, granite serves as the base rock. As this granite breaks down over thousands of years, it releases a specific set of minerals: silicon, oxygen, potassium, aluminum, calcium, sodium, iron, and magnesium. These elements are the building blocks of the savanna landscape. For instance, when silicon and oxygen combine, they create quartz, which gives the savanna its famously sandy texture. When silicon is joined by iron and aluminum, it forms the dense clay layers that trap moisture. You might also notice that savanna soil often has a distinct yellow or reddish tint. This coloration is a direct result of the high presence of iron and magnesium. While we often think of these as just minerals in the ground, magnesium is actually essential for life here because it is a core component of chlorophyll, which plants need for photosynthesis. However, the most defining characteristic of savanna soil is its acidity. This is measured on the pH scale, which stands for the power of hydrogen. On this scale, a value of 7 is considered neutral. For context, clean rainwater usually has a pH of about 5.6, and healthy tropical plant life generally thrives at a slightly more balanced 6.5. In the Belizean savanna, however, the pH levels drop significantly, typically registering between 4 and 5. In some upland areas, it can even plummet as low as 2.7. This level of acidity is so intense that it is actually toxic or inhospitable to the vast majority of tropical plant species.
This is why the lush, dense jungle of the broadleaf forest suddenly stops and gives way to open grassland. The soil simply won't allow most trees to grow. This high acidity, combined with the lack of nutrients and the tendency for the ground to become either a swamp or a sun-baked crust, results in what we call low fertility. Only the most specialized plants, like the Caribbean pine and the saw palmetto, have evolved the chemical toughness to call this acidic, mineral-heavy ground their home. Understanding the chemistry of the environment helps us better understand the chemistry of our own bodies, particularly when it comes to the water we drink and the minerals we consume. The concept of pH, or the power of hydrogen, isn't just a measurement for savanna soil. It is a critical factor in human health. In the savanna, we see soils with high acidity, often ranging between a pH of 4 and 5. While plants have to adapt to these harsh levels, humans also face significant health implications when our internal balance is disrupted by highly acidic or mineral-heavy intake. One of the most direct connections between environmental minerals and human health is the formation of kidney stones. In regions where water is very rich in minerals, like calcium, often referred to as hard water or water influenced by limestone, these minerals can accumulate in the body. When the concentration becomes too high, the minerals begin to coagulate and harden within the kidneys. These stones can vary in composition. Some are incredibly hard, while others, much like the limestone found in Belizean caves, can be more brittle but just as painful.
The physical toll is significant, often requiring medical intervention or even surgery to remove the buildup. It serves as a stark reminder that the same elements forming the bedrock of our landscapes, like calcium carbonate, are processed by our internal systems every day. Beyond natural mineral intake, the acidity of the beverages we choose plays a massive role in our well-being. Many popular soft drinks, such as Coca-Cola, are highly acidic. To put their potency into perspective, the acid in these drinks is strong enough to dissolve corrosion on a car battery terminal.
When we consume these liquids, that same acidity enters our digestive tract, where it can irritate and eventually destroy the stomach lining. Furthermore, high consumption of these beverages is frequently linked to the recurrence of kidney stones. Doctors often warn that if a patient continues to drink highly acidic, sugar-laden sodas after a procedure, the stones are likely to return. Even common habits like drinking coffee require a level of caution. While caffeine itself can have health benefits when consumed without sugar, coffee is still an acidic beverage that can contribute to mineral crystallization in the urinary tract. The goal is to maintain a balance. Just as the savanna ecosystem relies on a specific mineral composition to support its unique flora, our bodies require a balanced pH and the right amount of minerals to function without developing painful complications. Staying hydrated with clean, filtered water and being mindful of the acidic battery acid found in processed drinks is essential for long-term health. By respecting the power of hydrogen and the minerals in our diet, we can avoid the internal stony buildup that mirrors the very geology of the Belizean wild. While the savanna might look like a simple, empty grassland at first glance, it is actually one of the most hard-working ecosystems in Belize. One of its most critical roles is acting as a massive carbon sink. In the same way that a dense rainforest absorbs carbon dioxide, The savanna helps to absorb greenhouse gases from the atmosphere. Because the savanna is so open and exposed to the sun, the soil and the specialized vegetation are constantly working to trap these gases, which helps mitigate the effects of climate change.
It is a quiet but powerful defense mechanism for the entire planet, tucked away in these flat, sandy plains. Beyond its role in the atmosphere, the savanna serves as a vital hydrological sponge. During the intense rainy seasons in Belize, the land often becomes waterlogged. You might see what looks like a flood, where the water just sits on the surface, but this is actually a positive environmental service. The savanna soil, which is often a mix of sandy topsoil and impermeable clay, has a remarkable capacity to store large amounts of rainwater.
By holding this water, the savanna prevents it from rushing all at once into the river systems and toward the coast. If the savanna didn't exist to soak up this saturation, coastal locations like Belize City would face significantly higher risks of devastating floods. The land essentially captures the overflow, allowing it to drain slowly and safely, rather than overwhelming human settlements. This water storage also plays a surprising role in protecting the Mesoamerican barrier reef. When heavy rains wash over the land, they carry silt and sediments. The savanna acts as a natural filtration system. As the water moves through the grasses and the roots of the pine trees, it slows down, allowing sediments to settle rather than being washed out to sea. This prevents the reef from being choked by murky water and pollution. Even the seagrasses along the coast work in tandem with the savanna to clean the water before it reaches the delicate coral structures. Furthermore, the savanna acts as a physical shield. Positioned between the sea and the interior, these vast stretches of land serve as a natural windbreak.
When powerful sea breezes or hurricanes push in from the east, the scattered clumps of oaks and hardy Caribbean pines help to break the force of the wind, weakening its impact before it reaches further inland. The roots of these plants are equally important, as they anchor the sandy soil and prevent erosion during these extreme weather events. Even though the savanna lacks the thick canopy of a broadleaf forest, its specialized, tough vegetation is perfectly adapted to stand its ground, protecting the structural integrity of the coastline and ensuring that the nutrients in the soil stay exactly where they belong.
When we look at the Belizean landscape, it becomes clear that savannas are not a single monolithic ecosystem. Instead, they are defined by their elevation and location, categorized into two distinct types: the upland savanna and the lowland savanna. The upland savanna is famously represented by the Mountain Pine Ridge area. This region sits at a significantly higher altitude, generally between 2,000 and 3,000 feet above sea level. Because of this elevation, the climate is noticeably cooler and wetter than the coastal regions, with temperatures averaging around 72 degrees Fahrenheit and rainfall reaching approximately 74 inches annually.
The soil in the upland savanna is a study in geology. It consists of shallow silicon dioxide derived directly from the massive granite bedrock that sits very close to the surface. If you travel through this area, you will often see exposed slabs of this granite, which determines the unique chemical makeup of the ground. In these highlands, the forest is dominated by two specific species of pine trees. The first is the Pinus caribea, also known as the Caribbean pine, and the second is the Pinus patula, or Pinus ocarpa. A fascinating way to distinguish between these two trees is by examining their needles. If you look at the tip of a branch, the Caribbean pine typically features 3 needles in a cluster, while the Pinus patula boasts 5. This variety is a hallmark of the upland savanna, as the patula species thrives specifically in higher, cooler elevations that the coastal plains cannot provide. As we move away from the mountains and toward the Caribbean Sea, the landscape transitions into the lowland savannas.
These areas are found along the coast of Belize and are characterized by their flat, open terrain near sea level. Unlike the upland regions, the lowland savanna is home to only one species of pine, the Caribbean pine. These coastal savannas are further divided into 2 major categories based on their location relative to Gales Point. North of Gales Point, the land is more karstic, featuring porous limestone that results in a sandy topsoil. In contrast, south of Gales Point, the soil is primarily composed of nutrient-poor acidic quartz. While both ecosystems share the classic savanna appearance of vast grasslands dotted with solitary trees, the differences in their underlying soil and climate are profound. The upland savanna is a rugged, granite-based mountain frontier with a greater diversity of pine species, while the lowland savanna is a coastal expanse defined by sandy, acidic soils and seasonal waterlogging. Recognizing these two variations is essential for understanding how Belize's unique topography creates such specialized habitats for the plants and animals that call these grasslands home.
In the Belizean savanna, fire is not a sign of destruction, but a vital mechanism for life and renewal. The pine trees that dominate this landscape, particularly the Caribbean pine, have evolved sophisticated biological strategies to not only survive the heat, but to thrive because of it. If you walk through a savanna after a fire, you might see trees with blackened, charred trunks, yet these trees are often still very much alive. This resilience is primarily due to their specialized, thick bark. This bark acts as a thermal shield, providing heavy insulation for the tree's internal systems. While the outer layers may scorch and burn, the delicate living tissues inside, the parts of the tree that transport water and nutrients, are kept safe from the lethal temperatures. This evolutionary armor allows the pine tree to stand tall while the surrounding grasses and shrubs are cleared away by the flames. Beyond just surviving the heat, these trees actually require fire to reproduce. This process centers on the pine cones, which serve as protective vessels for the seeds. In many cases, these cones are sealed shut by a tough resin that keeps the seeds trapped inside for years.
It takes the intense heat of a fire to melt this resin, triggering the cones to pop open and release their seeds. This is a brilliant survival strategy because it ensures that seeds are only released when the environmental conditions are most favorable for their growth. Once the fire passes, the seeds fall onto a forest floor that has been cleared of competing vegetation and thick leaf litter. Furthermore, the fire converts dead organic matter into nutrient-rich ash, creating a fertilized seedbed that gives the new generation of pines a head start.
This dependency on fire is so integrated into the ecosystem that it is regularly managed by the Belizean Forest Department through what is known as controlled burning. By using fire lines to contain the flames, rangers can stimulate the rejuvenation of the forest. Without these periodic fires, the pine seeds would remain locked away, and the savanna would eventually be overtaken by other species. The pine trees also contain high levels of flammable resin, the same substance historically used to produce turpentine.
While this makes the trees catch fire easily, it is all part of a cycle that ensures the forest remains young and healthy. When you look at the rugged pines of the mountain pine ridge or the coastal lowlands, you are looking at masters of adaptation, trees that have turned the threat of fire into their greatest ally for survival and growth. Life in the Belizean savanna is a masterclass in adaptation, where the plants and animals have developed fascinating strategies to handle the acidic soil and open, exposed landscape. Because the environment is so demanding, the flora here is remarkably specialized. One of the most intriguing plants you will encounter is the sundew. These are tiny, carnivorous flowers that thrive in the moist areas near granite rocks and streams. Since the savanna soil is notoriously poor in nutrients, the sundew has evolved to get its sustenance from another source: insects. Its leaves are covered with glistening, sticky droplets that look like sweet nectar but act like glue. When an insect lands, it becomes trapped, and the plant slowly closes its leaves around the prey, digesting it to gain the nitrogen and minerals the soils simply cannot provide. Another iconic savanna resident is the sandpaper tree, which earns its name quite literally. If you feel its leaves, they have a rough, abrasive texture that feels exactly like a piece of industrial sandpaper. In fact, people in Belize traditionally use these leaves to scrub pots and pans, or even to sand down wood. But beyond its utility to humans, the tree's tough leaves are a defense mechanism against herbivores who find the texture unappealing. You will also see the krabu tree, which produces small yellow fruits that are a favorite for local parrots. These birds are skillful enough to eat the pulp and discard the seeds, which helps the tree spread throughout the grassland. The animal life in the savanna is equally unique, often blending in perfectly with the landscape. You might spot the yellow-spotted spiny lizard, a creature easily identified by its stout armored body and the spikes along its tail.
In the mountain pine ridge, the bird life is particularly vibrant. The acorn woodpecker is a standout, known for its industrious habit of boring holes into trees to store acorns. These birds create massive granaries, stuffing acorns into the bark to ensure they have a food supply that lasts through the year. Among the pine trees, you might also catch a glimpse of the hepatic tanager, where the bright red males contrast beautifully against the green needles. In the lower savannas, the yellow-headed parrot finds its home, often nesting in abandoned termite mounds or holes in pine trunks.
While these parrots are unfortunately endangered, they remain a symbol of the savanna's biodiversity. For those looking at the ground, the savanna is also home to the gray fox, a native species that is surprisingly arboreal, meaning it can climb trees to hunt for birds or find safety. Even the apex predators like the mountain cow or tapir frequent these open spaces after a rain to feed on the fresh young grass. Each of these species, from the tiny insect-eating sundew to the industrious woodpecker, plays a vital role in the delicate balance of this sun-drenched ecosystem.
Transitioning from the open savannas, we arrive at the vital world of Belizean wetlands, a complex system that functions as the kidneys of the environment. Wetlands are not just soggy patches of land. They are essential for managing floodwaters and protecting coastal areas from storm surges. By absorbing excess rainfall, these habitats prevent catastrophic erosion and act as natural filters, trapping pollutants and sediments before they can reach the delicate marine ecosystems like the Great Barrier Reef. The root systems here are particularly remarkable, anchoring the soil and holding the landscape together against the force of intense tropical rains. Wetland habitats are primarily categorized into seasonal and permanent systems. Seasonal freshwater wetlands, often referred to locally as bajos or swamp forests, are transitional spaces. During the rainy season, these areas become waterlogged, creating unique feeding grounds for various animals, but they can dry out significantly during the hotter months.
You might find seasonal creeks and streams that run fast and full after a storm, serving as tributaries that drain higher ground into larger basins, only to disappear when the rains stop. In contrast, permanent freshwater systems like lagoons and rivers maintain water year-round. Lagoons, such as the famous Crooked Tree Lagoon, are permanently waterlogged areas that support an incredible density of life. These bodies of water are crucial for biodiversity, providing a home to everything from the apple snail to the massive jabiru stork.
Rivers and streams follow the path of least resistance from the highlands down to the sea and are typically divided into 3 sections: the upper reach, the middle section, and the lower reach. The upper regions, like those near the Vaca Falls, are often steep and prone to flash floods, requiring vegetation with incredibly strong root attachments. As the river moves into the middle section, it becomes wider and deeper, often flanked by giant trees like the guanacaste or the ceiba, which use massive buttress roots to stay upright in the soft, saturated soil. By the time a river reaches its lower reaches near the coast, it is deep, slow-moving, and influenced by the tides and sea breezes. The flora of these wetlands is just as specialized. You will find reeds, bamboo, and the provision tree, along with beautiful but invasive species like the water hyacinth. The wildlife is equally adapted to this watery world. The northern jacana, sometimes called the Jesus bird, uses its long toes to walk across lily pads, while the snail kite uses a specialized curved beak to extract snails from their shells. From the prehistoric-looking Moralett's crocodile to the iconic green iguana perched in the overhanging bamboo, these wetlands represent a high-stakes environment where every plant and animal has evolved to master the rhythm of the water.